All right, what's up, guys? In this video, we're going to pick up some more calculus here, and we're going to be talking about the telescoping series. So it says for the following telescoping series, we want to find a formula for the nth term of the sequence of partial sums. And they want us to evaluate the limit as n goes to infinity for s of n to determine if the series converges. All right, so they give us this series here. Basically, what a telescoping series is, just to be general with it, when you write down the list of partial sums, you'll notice for the telescoping series that all the terms, with the exception of the first and the last term, actually end up canceling out. They kind of collapse in a sense, and that just leaves you with the first and the last term. Now, to determine whether or not a series is telescoping, you need to, write out some of the partial sums and see what's happening, look at the behavior, and based on that, you can kind of tell whether it's telescoping or not. Obviously, in certain cases where you want to use, let's say, for example, you want to use the telescoping series tests, you have to make sure that the series is in fact telescoping before trying to use the telescoping series test on a series that's not telescoping. So you need to make sure it's telescoping before trying to use telescoping series tests. Excuse me. So they want us to find the nth term of the sequence of partial sums. So we just have to list them some terms out, and you'll see the behavior once we do it. So I'm going to pull the 11 out, and I'm going to write it as, we have our series from n is equal to 1 to n. And I just took the 11 out, and I'm going to write it as 1 over n minus this series n is equal to 1 to n. And it's going to be 1 over n plus 1. I'm going to write it like that. Now let's just plug in some values, and you're going to see how the inner terms will basically collapse. They'll fall out. So we still got 11 on the outside. So let's stick in a 1. And we're going to do this side first, then we'll do the other side. So this would be 1 over 1, which is just 1, but we'll leave it 1 over 1 for right now. Sticking in a 2, so we get 1 over 2. Sticking in a 3, we get 1 over 3. We could do 1 over 4. And it would basically just kind of keep going all to 1 over n. And I wanted to do it over there, but I'm not going to be able to fit it. So I'll just do it here. So then we'll subtract. And we're going to do the same thing. We're just going to plug in some values. And you're going to see what's going on in a moment. So if we start subbing in some values here, we'll get 1 over 2 plus 1 over 3 plus 1 over 4, and basically so on. Now, look at essentially what is happening. Notice how the 1/2 go, the 1/3 go, the 1/4 go, and notice we're just left with that first and last term. So when we wrote out a couple of the partial sums here, or we started plugging in values, you can kind of see how all of those values on the inside are kind of collapsing. They're falling away. They're dropping out, so to speak. And every term but the first and last one is left. So that's why it's telescoping. So that means we just still got our 11, and all we're left with again, 1 over 1 is just 1. So we just left with 1 over 1 minus 1 over n plus 1. I'm going to simplify it a little bit. And how do I want to do this? I'll do n plus 1 minus 1 over n plus 1. And that'll just give us 11n over n plus 1. just kind of clean it up a little bit there. I basically wanted common denominators. That's what I did. And then I just put them all together. Okay, so now in this case, we have 11n all over n plus 1. Now, that's going to be the S of n right there. So S of n is 11n all over n plus 1. Now we'll take the limit. So we got the limit as n goes to infinity. And we'll have 11n all over n plus 1. So we can pull the 11 out. Maybe I should have left it out. That might have been a good thing to do if I just left it out. But I kind of just wanted to show you guys what was going on. So maybe I could have left it out there. So imagine it's just this, n over n plus 1. Now let's take the limit. And we still got our 11 out there. But so what's the limit for that? Well, to make it easier, you can divide by the highest denominator power, which would just be n. And so you would divide the top by n, the bottom by n. So you divide n by n and 1 by n. And so in that case, you have 11 times the limit as n goes to infinity. Dividing everything by the highest denominator power gives me 1 over 1 plus 1 over n. Now, we know that this is just we just have to look at the ratio of the first coefficient in the numerator and the first in the denominator, which is just 1 over 1, which is equal to 1. So we'll simply take 11 and multiply it by 1 and just get 11. So the limit as n goes to infinity for 1 over 1 plus 1 over n is just 1. We multiply 11 by 1, we get 11. And that's our limit. So our final answer, we know it converges because, of course, we get a finite value. So when we do the limit as n goes to infinity for S of n, we simply get 11. That's your answer. So they just wanted us to validate that. And obviously, it converges. That's pretty much how you do it. So, seems like a stupid process. Seems kind of long, seems kind of useless, but we have to go through and do it to validate that it's telescoping and, go through the whole process. A lot of things in math may seem kind of stupid, seem like, okay, why are we doing this? But at the end of the day, there's a reason behind it. So that's your answer. All right, so let me know if you got any questions about it. I'll try to address it. So I'll see y'all next time.